Today we'll be talking on the electrostatics, one of the most interesting concept of physics, that is electrostatics. We'll be talking on it. And yes, we are running the online classes. If you people are interested, definitely please go ahead and like, comment, and share this video. And if you want to join classes, online classes, you are all welcome. We generally conduct classes for JEE, Neet, ND, and Afcat batches for students, those who are really interested. Other than that, we have weekend batches for 10 plus 2 students, CBSE, State Board, and Cambridge Board. Okay, so for these three boards, other than that, hi, I am Aditya Mishra, and today we'll be talking about electrostatics. So, what is electrostatics and why it is important? Some of the fundamental concepts, which is very important, and especially when you are learning physics, it is very important to enjoy physics. If you don't enjoy, it becomes a burden. So, we'll try to make it very easy, and for all the JEE and NEET aspirants, it is an interesting thing. Okay, so let's begin with starting with first of all what is electrostatics. So as you can see, the name itself suggests electro. Electro actually means electrical charges. Okay, and statics means the stationary. So electro basically we have here meaning as electrical charges. Okay, and statics means stationary. So we generally when we talk about electrostatics, in electrostatics topic we study about electrical charges which are not moving, they are standing, or they are at rest at one particular place. Okay, so, but when we talk about electricity, we study moving charges. So actually talk about how the electrical charges they are moving and what effects are produced when the charges starts moving. Okay, here in this case, in the present case, the electrical charges they are not moving at all. They are standing at one particular place, and because of these charges standing near to each other, what is happening, what are the physical phenomena that is taking place, that we study in electrostatics. So like I told you, electrostatics is nothing but electro actually comes from some the name called electrical charges, and statics means stationary, which means not moving. Okay, they are at a particular place. So before we proceed, we know that every atom, uh, the size of an atom is close to 10 to power between 10 to power minus 10 to 10 to power minus of 15. So they are very small. The atoms are basic building block of all the non-living life that we see around us, like a table, chair, fan, a very big basket. Everything is made up of these atoms. Okay, so these atoms, why they are important? Because they are the atoms are the basic building block of all the objects or non-living things we see around us. Okay, now every atom basically has a centrally placed nucleus. There is a nucleus in the center, and there will be number of electrons which will be revolving around the nucleus in orbits. So these are shells or orbits. In these shells and orbits, the electrons will be revolving around the nucleus, and we all know that there are another subatomic particles. So these are smaller than atom, therefore we call them as subatomic particles. We generally have three, we are known to three subatomic particles in your, according to the textbook if you go. So there will be proton, there will be neutron, and there is an electron. Many other things are present in the nucleus, but for the time being we'll go with what is there in the textbook. So there are proton, which we call it positively charged. So these are positive charges. Like I told you, electro refers to electrical charges. There are only two types of charges. One is positive charge, which we use to denote proton, and then we have a negative charge which we use to denote an electron. So these are only two electrical charges that we study, that we talk about: positive charge and a negative charge. There is something else in the nucleus present which has no electrical charges. This is called neutron. Okay, so no charges. So we have a proton, three subatomic particles are present. One is called proton, another is referred as electron, and the third one we call it as neutron. Inside the nucleus, if you go, if you study, you will find out that there is constant conversion happening between the protons and the neutrons. Okay, they constantly keep converting into one another, but at a time, if you go, there will be fixed number of electron. If we what you can say stop the conversion process, we pause it, then we will have certain number of electron and certain number of protons. Okay, so there are three subatomic particles. Listen to the word subatomic particles. Okay, one is proton, neutron and electron. Now every electron has actually allotted an electrical charge. It is given, people found out, scientists found out that every electron and every proton has same electrical charge which are opposite in magnitude. For example, when we talk about an electron has a charge of 1.603 into 10 to the power minus of 19 coulombs on it. The same amount of charge is present on proton, but then the proton will have a positive charge which is 6.03. Actually, it is 2999, but we bring it down to 3 into 10 to the power minus of 19 coulombs. Okay, so every atom is made up of electrical charges. There are only two electrical charges. One is called proton and another is called an electron. The neutron is a neutral entity which is present inside the nucleus, and as we know, the electrons actually keep revolving around the shells. Okay, so now we know that there are only two charges. Now when these two charges actually they are placed close to each other, for example, here you can see there is a positive charge here and there is a negative charge here, so we call them as unlike charges. Okay, so when two unlike charges are placed close to each other, they attract. So there will be something called attraction. The opposites always attract. You might have heard this proverb. So when opposite charges are brought close to each other, they always attract each other with some force. There will be some force which will be trying to pull these two things, two electrical charges together. But if we put like charges, for example, here we have minus charge and negative charge, and if we put plus charge and plus charge also, the result will be the same. So these are called like charges. So there is something called like charges which have similar nature and unlike charges which have different nature. So when two like charges are placed close to each other, then you can see they are trying to move apart from each other. This is called repulsion. Okay, then again there will be some force with which they will get pushed each other. If you push two like peoples together, they will look at each other and there will be some force of repulsion. Okay, so this is what we need to pay attention. Force of attraction when there are two unlike charges when placed, and force of repulsion when two like charges, two electrical charges of negative nature or positive nature, when placed together, they will exert or apply a force of repulsion between them. So in electrostatics we have force of attraction also, and then there will be force of repulsion also. Okay, and but if you go to gravitation, in gravitation there is only, when we talk about gravitational forces of attraction between celestial objects or maybe a planet in itself, then there is no force of repulsion. There is only attraction. In gravitation, there is only force of attraction. Now the question is, okay, interesting thing is we have a positive charge here and we have a negative charge here. We do also have two negative charges close to each other, but then there is a force of repulsion, there is attraction. How much is this force? We don't know the magnitude. Everyone know that force is a vector quantity. Okay, so you need to have two things. We need to have magnitude, plus we should also have a direction. But uh, people when found out, scientists when found out in early, you can say 18th or 19th century, uh, we were not aware how to find out what kind of a force, how much amount of force is actually applied between the unlike charges, and same is true for like charges. How much, what is the value of force. Okay, so that is calculated using, so Andrew Coulomb, actually he gave a law that helped us to calculate this formula. We will see in a coming part. Okay, so I hope everyone is clear. Electrostatics actually refers to electrical charges at rest, not moving, they are stationary. Okay, and every atom has three subatomic particles generally, which you might you come across in the books. There is a proton with a positive charge, charge number 1, and there is electron with a negative charge, charge number 2. Third subatomic particle has no charge, it is just there to balance the energies or balance the forces between the positive and negative charges. Okay, and when we put unlike charges, there is force of repulsion. When we put like charge, sorry, when we put unlike charges, there is force of attraction, and when we put like charges, there is force of repulsion. So these things we have to keep in mind, and let's move on then. Charging by induction. Now, one of the most important property that we need to understand when we go for electrostatics is induction. So what do you mean by induction? We have written it here in small, in few words we can call it, it is a method how to charge an object. So you have a neutral object, for example, let's say a neutron is there. Okay, let's say we have a charge, not neutron, let's take a metal sphere. So this metal sphere, as you can see here, there are two metal spheres kept next to each other. Okay, this has no charge, it's neutral. The second one is also has no charge, that is also neutral. Okay, so when two charge neutral conductors are brought close to each other, and yeah, method of electrically charging a neutral conductor without direct contact. We are not even, let's imagine there is a space between, gap between the two sphere using an externally charged object. So we have a balloon, as you can see in this, we have a balloon. This balloon is negatively charged. When a negatively charged balloon is brought close to the neutral sphere A, okay, when a negative charge is brought close to the neutrals, this cylinder, like I told you, when a charged object is brought close to a neutral object, then the neutral object automatically develops opposite charge. How this happens, why this happens, we'll talk about it. So when a negative charge is brought close to sphere, it automatically gets positively charged. And because this is positively charged and it is close to the sphere B, then sphere B will develop an opposite charge. So I hope you understood. Induction basically means charging an object without touching it. Okay. So when we bring a charged object in close proximity, they are not touching each other. But if we are bringing close to it, the automatically a positive charge is developed, because sphere A has got a positive charge developed on it. Automatically there is a negative charge developed on the surface of cylinder B. Okay, so similarly here you can see the charges has developed. This is charged conductor. Okay, when you remove this negative charge, now automatically this negative charge will force positive charge to stay on sphere A, and this positive charge is forced to stay with negative charge. So charges are automatically developed and they are constantly present over there. Now how this thing happens? So you might have taken an example of a comb. Okay, so here let me go back to the first page. You can see here comb. So this is a comb and this is a piece of a paper. Okay, when a charged comb, when you rub this comb on your hair, okay, there is charge which gets induced on the surface. So let's say it gets negatively charged. When we rub this comb on our hair, it becomes negatively charged, and this piece of paper is actually neutral here. Okay, so neutral means the number of positive charges will be equal to the total number of negative charges which are present inside the paper. So let's say if it has 10 positive charges, the piece of paper will also have 10 negative charges. Okay, now when you bring a, so everything is balanced inside this piece of a paper. Every plus charge is present with a minus charge, plus 10 plus 1 minus 1 equal to 0. Now when we bring a negatively charged comb close to the piece of paper, what happens is the positive charges actually gets attracted towards the negative charge, and all the negative charges are left aside because of the presence of a negative charge. So what happens is all the positive charges are pulled to one side and all the negative charges are left alone. Okay, so therefore what happens is one of the side where this negative charge is brought close to the piece of paper, it becomes positive charge. So this side will have a positive charge. Because this side has a positive charge, the opposite side will develop automatically a negative charge. So initially the piece of paper was neutral. Okay, when we brought a number of proton was equal to number of electron, and when this comb was brought close to the piece of a paper, automatically the positive charges got attracted towards the comb, and one side of this piece of paper gets positively charged, other side gets negatively charged. So this piece of paper will get attracted towards the comb, and then you can see they are sticking to it. Same is true with the balloon. If the balloon is negatively charged, one side of the piece of a paper will get positively charged and they will get attracted because of a force which is called electrostatic force. So there are electrical charges here. There are electrical charges here. Proton, electron are present inside the balloon also, inside the atom of balloon, and proton, neutron are also present inside the piece of a paper. So this is called induction, which is one of the most interesting thing in electrostatics. So this is how the charges are actually developed. Interesting thing to understand what is actually induction. So I hope everyone understood what is induction or charging by induction. If we want to charge something, a neutral object, then we just have to take a charged object very close to it, and then it will automatically start building charges on it. Okay, so this is how the principle. It is one of the key principle of electrostatic induction. So this is called electrostatic induction, bringing or developing an electrical charge on a neutral object. So this is the second thing. Then like I told you, there are two kinds of forces. One will be force of attraction, because of the charges are having different nature, unlike always attract. Okay, and then second thing is we have here again the force of repulsion is also there. So therefore we will have a force of repulsion. Positive and negative attract each other. Here negative and negative will also attract each other. So there are two forces, force of attraction and force of repulsion, but we don't know how do we measure it. How do I find out how much force, magnitude or value of force is there? Direction is clear. They are attracting towards each other, and these directions are moving away from each other. So these forces actually they act along a straight line. This is called line of action. So the forces which are acting on the charges or along which the forces are acting, this is called line of action. So two forces are actually acting along a straight line, which is known as line of action. Okay, so Coulomb, Andrew Coulomb, who is interested in these studies, actually he came up with a formula that is called Coulomb's law. Now, what does this Coulomb's law say? Coulomb's law simply says that if you have two charges, okay, so for example, let's say, like I have shown it in your picture, this is charge number one. It will be having some charge into 10 to power minus 3 coulombs. Okay, and this is the second charge. Again, if you can see here, there are unlike charges. So this is a positive charge, that is a negative charge. There will be force of attraction along the line of action. So Coulomb actually he put up a law. Acha, what is basically a law? Law is universal truth. It is true everywhere. So if it is true here, it is true on another planet also, and another planet also. Now the question is, how do we know that it is true on this planet, that planet, another planet also? Because we have never been to another planet. Okay, so that remains a question which I would like all of you to find out answer to this question, which is very interesting. Okay, so here Coulomb actually gave a formula. Okay, he built a law. He gave a formula to calculate how to calculate the amount of force. So electrostatic force, he actually said that if we have two charges, whether they are like charges or whether they are unlike charges, it doesn't matter. We have to have two charges. Okay, it could be of different nature or same nature. So if we have two charges, and let's say the two charges they are kept at a distance r apart from each other, the two charges are placed away from each other. So this the force is proportional to the product of the magnitude of the charges. You take the product and you take the magnitude of the two charges. Okay, so first thing which he told is this. uh, the same thing we talk about, same kind of rule is actually given in Newton's law of gravity. If you talk about gravity, applies the same rule, and it says that the force actually increases and decreases following a square of the distance between them. So typically, as you can see here, if we are talking about force acting on the second charge, so this is the second charge. This shows that the force acting on second charge because of the first charge, and here force acting on first charge because of the second charge. Okay, so this is the force because of this second charge which is experienced by positive charge, and force experienced it by the second charge because of the first charge. We write it like both of them are equal, but they are opposite. So force acting on first charge because of the second charge will be more or less equal to force acting on the second charge because of the first charge. Now the question is why I have put a negative sign here, because the force is a vector quantity. Okay, so this is a vector and this is a vector. Direction is very important. So this force is having, let's say, magnitude of 10. It is acting in this direction. Then if you write minus 10, that means if this is plus 10 acting here, if we write minus 10, it will automatically change the direction. So if how to find out these forces? According to Gauss law, we can find it as some proportional here. So simply we write this as proportional to Q1. So this force depends on, you can see, the magnitude of charges, and the same force they also depend on the distance between the charges. Okay, so in order to remove this relation, this is called a relation. When you remove a relation, it becomes an equation with a constant which is q1 into q2 divided by r square. Okay, so yeah, so this will become q1 into q2. Okay, we have here q1 into q2 divided by r square. That's what we have. And then f will be is equals to what? F is going to be equals to k times of q1 first charge into q2 second charge, and divided by distance square, which is r square. So it simply shows that the force depends on how strong the charges are. If you have 1 coulomb, the force will be weak compared to 10 coulomb. If the charges are of 10 coulombs, generally we go for micro coulomb forces, which are very small compared to coulomb forces. So here both the forces can be written in terms of k is into q1 into q2 divided by r square, whereby this k is called constant of proportionality constant. Okay, then this proportionality constant, the value of this k will keep on changing, but then for the time being we will write it as k divided by 1 by 4 pi epsilon 0. Okay, this epsilon 0 is called permittivity of free space or vacuum. Okay, this is the value which scientists actually found out, and it comes around to be as 9 into 10 to power 9. That is what we have to see. Okay, so the value of k is 9 into 10 to power 9 if it is vacuum or air, or if it is in given medium, then something else comes into the picture which is called dielectric constant, and then we multiply this dielectric constant to it. So anywhere if we want to calculate the force between the two charges, the formula should be, those who are preparing for JEE and Neet and other things, they should be very clear about this. The value is 9 into 10 to power 9. And let's say if both of them are of 10 microcoulomb, this is 10 microcoulomb, that is also 10 microcoulomb. So like charges, both the electrical charges are like in nature. We are not talking about the direction. So then in that case, this will become q square and divided by r square. Okay, so the formula becomes, actually the formula becomes f12 into 21 kq1 into q2 by r square, and f is equals to 9 into 10 to power 9. This becomes q square divided by r square. Okay, so F is equals to 9 into 10 to power 9 Q1 into Q2 by distance square. That is called Coulomb's law. Actually, Coulomb's law gives us the formula to calculate force. That is why magnitude of force. That is why it is one of the most important thing, and it is similar to the Newton's law of gravitation. This K is called constant of proportionality. Epsilon 0 is called permittivity constant. Okay. Then next is principle of superposition. Most widely you will come across these kind of problems if you are from CBSE, if you are from NCERT, if you are appearing for national level examination, you will definitely come across these things. So what does this principle of superposition say? States it states that principle of superposition actually states that the total force on any charge due to number of other charges surrounding it is vector sum of all the individual forces on that. So for example, let's say this is our charge number 1. We'll come back to this picture later. This is first charge. Let's say it could be positive and negative. We'll write this as charge number Q1. So if we have charge Q1 and let's say we also have this as second charge, this second charge is nothing but Q2, and then we have this as third charge. This third charge is nothing but Q3. So there are three charges. We know that from Coulomb's law, if two charges are placed close to each other, then there will be force. If let's say this is a positive charge, this is positive charge and that is negative charge, there will be force of attraction. So this will be the direction of force and the force acting on. So we are interested in force which is acting on first charge. So force acting on first charge because of the second charge F12 will be given from Coulomb's law, which is K charge Q1 multiplied by charge Q2, and then that will be divided by distance square. So let's say we'll keep it as R1. Let's say R1 is the distance between the two charges. Then let's say we have a third charge also. So the law says that the first charge will be experiencing a force because of second charge, and the first charge it will also be experiencing a force because of the first charge. Let's say this charge is negative. Okay, so this is a positive charge and that is a negative charge. This charge will also experience a repulsion because, sorry, let's keep it as positive charge. So because both the charges are in nature like in nature, there will be force of repulsion. Now this force of repulsion, so we have charge Q1 here, we do also have charge Q3 here. So this is a separate thing. Charge 1 is actually experiencing force because of second charge separately, and then imagine that it is second charge is not there, then there will be a force which will be acting on first charge because of the presence of third charge. So because of these two charges in the surrounding, there is another charge force acting on it, which is given by K is equals to Q1 multiplied by Q3, because there are charge 1 and 3 involved in this process, and then we will keep it as R2 square. Okay, so this is force because of on first charge because of the second charge, and this is force because of on first charge because of the presence of third charge. In simple terms, simple language, uh, principle of simple superposition says that the total force which is acting on the first charge will be the sum of the charge acting on first charge because of the second charge, force acting on okay, maybe there is some representation here, we made mistake. So force acting on first charge because of the second charge, plus here there will be force acting on first charge because of the third charge. So this is vector sum because force is a vector quantity, so the total resultant will also be a force. Here we are not considering the vector properties, we are only talking about magnitudes. So when we consider vector, we have to go for vector notation. So let's say, as you can see here, there are three charges. This is charge 1. So I hope you understood. In simple language, total force will be the force because of all the charges that are present in the surrounding of the electrical charge. Okay, so there are three charges. We have charge Q1, we have charge Q2, and we do also have charge Q3 here. Then if we take a vector notation in XY coordinate system, here the vector position, or you can say the vector which gives the position of charge q1 is r1. Okay, position vector, so this is called position vector. So position vector r1 gives the position of distance of charge q1. Position vector r2 gives the distance of the charge q2 from this particular point, from point o. And that is position vector r3 gives the position of the charge q3. Okay, but we are interested in between distance between charge 1, and we are interested distance between charge 1 and 2. So this distance between charge 1 and 2 is called displacement vector. So the displacement vector gives the distance from point 1 to point 2. Okay, here, so position of, so distance from point uh, 1 to point 2, it goes like this. So the vector, this displacement vector r12 gives the distance between 1 and 2 charges. Similarly, we will have here position vector 1 and 3, which gives the distance between charge 1 and 3. In vector notation, the same Coulomb's law can be written in terms of 1 by 4 pi epsilon 0, and now we know that this is nothing but 9 into 10 to power 9. If the charges, if the three charges, they are placed in vacuum or free space, that means more or less air is present there. If air, vacuum and charges are present here, then the value becomes 9 into 10 to power 9. For free space and vacuum, the value is k into 10 to power 9. If not, if the charges, electrical charges are placed in water, for example, or in kerosene, then we will end up getting divided by k. Okay, so simply we have to put here the two charges q1 and q2, and then in the denominator it should be r12 square, and then we have to write this position vector to be n. When you take the magnitude, this whole thing becomes 1. So we end up getting the same formula k q1 into q2, and that has to be divided by distance here. So this is force between 1 and 2. Okay, same you can, it can be written here, and this is the force between 1 and 3 in vector notation. So what we have understood here, same thing is presented in vector form. So total force will be f1 and 2 plus 1 and 3. That means it is calculated in this, force 1 and 2 is calculated using this formula, force 1 and 3 can be calculated using this formula. Okay, so you will face numerous problems in your textbook, NCRT, in CBSE, and in JEE. If you are preparing, you will see these kind of notations, vector notation appearing almost everywhere. Okay, so that's the principle of superposition. And then from the principle of superposition, let's talk about the concept of electric field. What do we mean by an electric field? So before we go to magnetic field, let's try to understand what is magnetic field. So let's say if we have a magnet, okay, because all the ideas in physics, they are related to each other. If you understand one thing, it will be easy to understand the second concept, and the third one, and the fourth one. So JEE and all these exams are everything related to funda. If the fundamentals are clear, then it's very easy to crack the exam. So we have a plus charge here, and we, let's say this is a north pole. Okay, so north pole is generally treated as positive pole or positive charge, and here we have a south pole. So then we know that up to a certain distance, if you have an iron filing an object, up to a certain distance, this iron filing will get attracted. Okay, but if you place, so if it is over here, okay, if the iron filing is placed here, the magnet quickly attracts it, and it will be sticking to the magnet. But if we place this magnet little bit away from the magnet, then it will not attract the filing. Why? Because there is a certain limit to which this magnet, how strong. If the magnet is very strong, it can go attract in larger area. If the magnet is very weak, or maybe marginally strong, so then it will be attracting only up to a certain distance. This distance is actually known as field, like we have in a cricket, a boundary outside which there will be four run. Okay, so here there is no boundary. Here actually there is a limit outside which this magnet is not going to attract. So that's called a magnetic field. Okay, and in this magnetic field is actually invisible. But if you have been through book and notes and studies, scientists or people who are studying, researchers, actually they have pointed out there is invisible lines that are present here. Okay, these lines they always start from a north pole, they end at a south pole. These are called magnetic field lines. Okay, so these are actually nothing but magnetic field lines. This magnetic field lines help in attracting or repelling the object. Same is true for this side. Everywhere in this field, in this magnetic field, there will be field lines which will be starting from north pole and will be terminating at entering at the magnet at south pole. Inside also they run from this. So every imaginary line always have to have or form a closed surface, which is very important when you talk about closed. When we talk about field, the lines they form a closed pattern. Okay, so this is the picture of magnetic field. The poles are, if we treat poles as a positive charge and this as a negative charge, automatically you can see same kind of a nature is seen between opposite charges which attract each other in charges, in electrical charges. So this is how the force of attraction looks like when we take a broader picture. Okay, when we go to details, this is how the picture looks like. These are invisible lines, so these are called electric field lines. The invisible lines which are present in case of an electric field, the charges are at rest. We are holding the two charges by hand and then we are trying to visualize what is happening inside this field. Okay, same. So this is we call it as electric field lines. Like we have the magnetic field lines. So like magnetic field lines, there are also electric field lines. If you see this picture, both of them are positive charges. Okay, so remember that whenever the field line actually emerges or comes out of a positive charge, it always ends looks for the negative charge. The positive charges lines, they do not contact each other. So this is again, these are the questions which you can see in NCERT 10 plus 2 exams, not in 10 plus 2, in 10th exam, in 11th standard, in 12th standard, you will study all these things which are very important. If you go to higher standard, electromagnetic flux and interesting things will be there. Okay, so it's important to understand the idea, okay, about these lines. So these imaginary lines, they are called field lines. Now there are certain property. So these, like I told you, these are imaginary lines, they are not visible to all of us. But if we draw a tangent to this line, so from the positive charge to negative charge, if we draw a tangent to this line, it will give us the direction of electric field. So where this force is actually acting. So you can see the force is acting in this direction. If we put a point and draw a tangent to this line, at this point it will give you the direction of force. So at this particular point, the force is acting in this direction. At this particular point, if we draw a tangent, the force is acting. So instantaneous, at every instant of time, at every point, we have taken a snapshot or picture of this field line and then we'll try to understand. So this is basically an imaginary line, and tangent to which gives the direction of, it gives the direction of magnetic field. Also very important thing is they always start from a positive charge and they end at a negative charge. Positive charges for the electric field lines. For magnetic field lines, inside the magnet also they travel. Inside the magnet, the field lines they travel from south to north. Okay, so important point, positive, exert lateral forces on each other. You can see here, like if the two lines are close to each other, they start pushing each other. Shoulder push, they give a shoulder push to the lines. Wherever the lines are very crowded, the force of attraction is strong. So we found out that near the electrical charges, the electrostatic force is very strong, but away from the electrical charges, as you can see here, the lines are away from each other. So this represents weak forces. So weak electrostatic force is there where the lines are separated from each other. Strong electric force is where the lines are crowded. So these are the important things which we need to know before we proceed for the understanding or solving questions in electrostatics, the formulae, the concepts, the terms which are available here. So for both JEE, NEET, even the students who are appearing for NDA exams, Afcat exams, and central medical examinations. Nowadays it is, in olden days it used to be AITMT, now they have made it common, NEET exam common to everybody. So this is interesting, and yeah, it is, we need to understand each and every concept present here. Then from the electric field, let's come to, so field is basically this region inside which the electrostatic force is going to attract. Like we have magnetic field, we refer this kind of a field, the boundary of this field is known as electric field. Okay, so this is the idea how the electric field is this. Now even if we take, now interesting thing is that if you take a magnet, okay, if there is a magnet, and if we break this magnet into two pieces, if we break this magnet into pieces, the broken pieces, they automatically develop another pole. Okay, so if this is pole broken and that side also gets broken somehow, so this is north pole and that is south pole, this north pole will develop some another automatically south pole, and this south pole will develop automatically north pole. So therefore magnets, they are termed as dipole. So by default every magnet has two poles in it, okay, and no one can change. If we break this magnet, bar magnet here, then automatically the broken pieces will develop another poles next to it. Then coming to electric field intensity. So what is this electric field line intensity? Now we know that every charge actually produces an electric field around it, and for a positive charge the electric field lines they start, and at the negative charges the field lines actually terminate, they stop, they end. Okay, now let's say, and in electrostatics every a single charge can also produce its electric field. Okay, so every charge, electric charge, is actually here called a monopole. Mono means one. Okay, so every charge can have its own field, even if the charge is stationary, it's not moving. Okay, it will have a certain field. If something enters, if another charge or if like charge enters inside its boundary, automatically it will be thrown out. Okay, so this is called force of repulsion. Okay, now what is electric field intensity? How do we measure? So these lines are actually like a rubber band. Okay, they automatically, so if something, if you bring a, if we bring a negative charge close to it, they, like a rubber band, it will shrink, the charge will come close to each other, and then it will come back to its initial position. Okay, so these lines are always present. These are like invisible spear, something is protecting this particular charge, or some force is present, no one can enter in this particular region. That region is actually electric field. Now every single line, like we have talked about a rubber band, every single line here actually they have uh, they exert force. So how to calculate the force? Because of this single charge, okay, because of this electric charge, these lines they have some force. Okay, so ratio of electrostatic force between the two charges, and to the, so let's say if we have a second charge, let's treat this as first charge, this is second charge, this is also a negative charge. Now this negative charge is trying to enter into this region. So then when two charges are close to each other, automatically Coulomb's law apply, and we have formula 1 by 4 pi epsilon 0 q1 into q2, and that should be divided by the distance between the two charges. Let's say r is the distance between the two charges. So distance between the two charges will become r square. Now when we divide the second charge, like say, okay, so force, because of force acting on second charge because of the first charge. Okay, so when we divide this force, Coulomb's law force, by the second charge, we end up getting how much charge is present in these lines, how much strength or how much force is present in this charge. Simply you can say electric intensity is nothing but force per unit charge. Okay, so you can actually see here calling as Newton per Coulomb. Generally we talk about force is measured in Newton and charge is measured in Coulomb. So the unit will be Newton per coulomb. Okay. So per unit charge, how much force is acted by? So we are removing the charge because force because of the second charge, and we are only calculating what is the field strength because of the first charge. So this intensity is nothing but strength of these web-like lines which are actually making web around it. Okay, so electric intensity is nothing but force by the second charge. Electric intensity is 1 by 4 pi epsilon 0 q by r square, where r is called a unit vector. Technically, this unit vector will become 1. It should be actually r cube in the denominator, because the unit vector will be given by the magnitude. So r and r will cancel here. We'll end up getting r square. So electric intensity is nothing but force per unit the second charge which is trying to enter the field of the first charge. Okay, and therefore the formula will become K is equals to simply Q1 divided by R square. We already know this K is called constant of proportionality. This is one of the very most important idea of how this formula for electric intensity, how do we calculate. So we have the formula for electric intensity. Then one of the most important thing where many people actually get confused is nothing but flux. What do you mean by flux? In simple terms, like I told you, flux is nothing but total number of field lines which are actually emerging perpendicular to the surface. For example, let's say you can see here. Okay, so if this is electric field, each line has a strength capital E. If it is a uniform electric field, every line has a strength of E, but you can see the lines are not at 90 degree to the surface. This is normal, which is 90 degree. So all the line has to be parallel to this surface normal. Okay, so this all the lines actually should be perpendicular to this surface normal vector, but they are not. Okay, so field lines, we calculate flux only when the field lines actually are perpendicular to the surface. So for example, there is a uniform electric field. So we'll talk about what is uniform, what is non-uniform electric field, what do you mean by charge density, surface charge density. There are few more concepts which we require when we are trying to solve a problem for JEE or Neet exams. The fundamental idea, so this is basically the idea of physics. What is physics? That's what we are talking about behind electrostatics or electrical charges. Okay, so when we say flux, we calculate flux by definition. The definition of the flux says that all the field lines present or crossing this surface. Okay, let's say there are n number of field lines which are crossing this surface, and if they are uniformly distributed on this particular way, let's say A is the, for example, let's say DA is the area. This is a small part. Let's take a small part of this surface, and the small part we will refer it as DS, or maybe DA. We will call it as a DA. So DA is a small part of the surface here, and the lines has to be perpendicular. If they are not perpendicular to the surface, we have to make them a perpendicular, which we can do mathematically. Okay, so flux in the small area is actually given as d phi is equals to intensity of every single line has the same intensity E, and then that intensity, because it is not 90 degree, these lines are not 90 degree field lines, we will make these lines perpendicular mathematically. It is done like this. So now E cos theta lines are this. So these are the E cos theta line because they are not 90 degree. If they are already 90 degree, then cos 90 will become, sorry, cos 0, it's going to become 1. Okay, this theta, it is going to become 0. Theta will become 0. So therefore cos of 0 will become 1. If the theta goes to 0, so then we will have here cos of theta, and from trigonometry we know that cos of 0 is nothing but 1. So therefore we have cos theta. So this is the strength of a single line. This is strength of this one line, but there are many lines which are present in this particular area, or let's say small area. So then we will write E cos theta into ds. Okay, if we want to calculate over a bigger surface or a larger surface, entire surface, we will write it as phi, and then we generally integrate it for this d phi on this entire surface. and then this can be also written as E into cos of theta into ds, where integral, so because E is constant for every line, and let's say cos theta is also not changing, so cos theta outside, and we write this as ds. So therefore the formula becomes E into cos of theta into the area dA. Sorry, this should be dA, and that should also be dA. So therefore, the total flux out of flux is basically nothing but total lines which are emerging or which are coming out of this surface perpendicular to this. So this will become E into cos of theta, and that has to be into area. If the lines are already perpendicular, for example, let's say we take a case where the lines are already at 90 degree, then in that case, this theta, this tilting theta will become 0, and the formula becomes phi is equals to E into A, one of the most important formula that we will need when we go to the Gauss theorem and applications of Gauss theorem, Gaussian surface when we talk about. Okay, and even when we'll come across capacitors, you talk about what is electric flux. When we are solving numericals, this is very very important. Okay, and let me see. Okay, so that's all for today. We have understood few things. Let me recap it for all of you. So first we talked about electrostatics, and also remember, we have here online classes for JEE, NEET, NDA students, even students those who are interested to study online for their exams. They can contact me on this particular number. This is my contact number. You can call me, and we'll talk. So electrostatics. So first of all, we talked about what is electrostatics, then what is induction, how do we do charge a neutral object by means of induction, then uh, what is the importance of Coulomb's law. We haven't solved any numerical problems here, which is very very important. So these are basic fundamental idea and physics, the science of physics. Okay, and then we have principles of superposition, which we have already talked about. The principle of superposition, and then concept of electric field. What is actually an electric field? It is nothing but imaginary line which is present, which is not visible to our eyes. Then we have field intensity. Field intensity is nothing but it is the strength of or force of every single line. How much force does every single line, actually electric field line, indicate? That's what this electric intensity tells us. And coming to next, most importantly, electric flux. Basic, very very important is inclusions of topics that we have studied here. So thank you very much, and we will meet in the next class. And do contact if you are interested.